Okay, hi everyone. My name is Paul Briozzo. I don't have a who I am slide. I'm a lecturer at University of Sydney. Started life as a draftsperson, became an engineer, applied for a job as a tutor at the university. 30 years later, I guess I'm here. So today I've been asked to come along by Karina as a kind of a speaker on a unit of study that we've been teaching for over 10 years now, manufacturing engineering, that she's played a very large part in. So I'm going to be talking about what has happened in terms of what we used to teach and the transition as we move along and expectations. Now, when I was asked to write down a brief, it was I didn't realise it would end up being this long, but how LabVIEW, conventional manufacturing engineering methods, CAD CAM methods have been integrated into coherent teaching, methodology delivered to mechanical and mechatronics students enrolled at University of Sydney School of Aerospace. So 4 lenses, I talk about lenses, and they're just perspectives on things. Karina and I have a perspective, students have a view, and collective experts here have a view, and there's also theoretical frameworks from literature and the like. So it's a kind of a nice little balance there of things that we've tried to achieve. All right, here goes. That work? Good. So where it all fitted in, a lot of this is I've got to give you the context. I think there's an ex-student here somewhere, which is good, but he's a 99. Hey, yes, or another one? Okay. Keep up the spirit. All right, so where did it all sort of fit in and where were we at? And the subject we ran was located in third year. It's called Manufacturing Engineering, a humble little thing. And we ran it I was involved for about 25 years. And then one day, I was involved in a spark ignition engine project and we needed to get data out of it. And I said, well, there's this thing called LabVIEW. It's a 1-week course. I'll go and do the course, come back and do the LabVIEW bit. And he said, yeah, that's a great idea. I did the course. Karina was the lecturer. I came back and realised, hang on, this is not easy. So phone call to Karina. She'd left, I think, NI by that stage. And I think we were her first customer. But anyhow, that's all history. So that's kind of where it fits in, sort of into the third year sort of program. And where it sort of started. Typically, our students start off obviously in first year, and I'm a mechanical person. I know a lot of you here are electrical, but there's some similarities. We eventually do meet at the end, and so we give them kind of hands-on mechanical kind of projects like reading engineering drawings, becoming familiar with CAD packages like SolidWorks. And they go off and construct little steam engines or air-powered motors like this. We introduce analysis and the like. So gradually they're developing their hands-on skills and the ability to sort of turn something that's just not just an idea into a physical kind of product, which is always good. Then they come to another unit of study called Design 1, which is a kind of a precursor to manufacturing. So students learn about tolerancing, more about engineering drawings. They get involved in a little competition of sorts, but no physical really products are yet created. And that sort of combines with FEA type studies in Design 2. I don't know if that one works. So we introduce them to stress analysis and the like using SolidWorks. And we use a finite element sort of solution for some of their designs. So that's, if you were to break up the kind of software that they've been exposed to, and we're going to go through in a bit more depth to some of it. I think this is on auto, I'm not sure. So we've got SolidWorks and machining software, LabVIEW. We talk a lot more about SolidWorks simulation motion, controversial topic. We get them into 3D printing and also a bit more automated CNC machining. That's a kind of the sort of software that we generally use. So what was in the content of this subject? called manufacturing engineering. It doesn't exist anymore, but we'll talk about why later. So it was kind of divided into two. You're looking at one side of it. I'm on the left, and Karina is sort of on the right. So you can kind of see typical, if you're familiar with mechanical stuff, CNC machining is when you're sort of developing CNC codes that drive a mill that machines something out. And that's a very dominant kind of industry in Australia in terms of manufacturing. But it can be applied to other bits, and we'll get to that. So there's also things like cutting forces, jigs and fixtures, structures and kinematics, casting, shrink fits, metal forming, welding processes, powder metallurgy, rapid prototyping, and a bit of a review. Now, there's also the automation part. So it's always week one, Paul, Karina, Monday, Tuesday, all the way through for 10 years or more. So on the automation part, see if I get it right. First of all, automation and testing, data acquisition, analog sampling, data processing, software design patterns, automated inspection, measurements in VBAI, measurements in OCR in VBAI. I know them by symbols and the like. VBAI tools of vision, motion control, and the like. So quite a lot to do in 3 months, just over 3 months. So these are students who typically have no exposure to LabVIEW. They're usually mechanical or mechatronics. So you begin to see a bit of a development. So unpacking this a bit more, I mentioned CNC, and that's the computer numerical control side. So it's just like writing very simple little codes, machining, how to machine a little slot. And over on the automation part, we've got product life cycle, that sort of introduction to LabVIEW, testing, very important. I always loved her first lecture because it got into the whole product life cycle thing, which we don't do too much of, actually. SolidWorks CNC machining, how to write codes using a simulation package. And then on the automation side, some bits on data acquisition, the Nyquist theorem, that kind of stuff. This may work. Let's have a try. Is it going to work? Yes. So we get to see a bit of machining in real time. So the students kind of do this kind of writing of code, and then you can see it sort of simulated. And WIPU, they learn in a couple of weeks. I couldn't get Karina's stuff to do that sort of thing, but you can kind of see some analog sampling that I'm sure you're all kind of familiar with. It then follows through, week 4, cutting forces, jigs and fixtures. And what Karina was doing there was on data processing. No funny graphics on that one. Structures and kinematics of machines, sort of using different types of arrangements of machines and controlling them. And Karina was doing state machines, software designs. I think that's a pretty difficult topic for students. Better than me, I suppose. I did casting in week 6, introducing students to more traditional kind of manufacturing processes. And I think Karina did a review on that. Week 7, part 2 of casting, introducing fluids and that kind of thinking into manufacturing. And Karina was doing automated inspection systems. In week 8, I was sort of doing shrink fits, how things were assembled together by either force, pressure, or varying temperature. And Karina was doing finding features in VBAI, bit of pattern recognition and the like in images. Always really interesting sort of stuff. My week 9, I was doing sheet metal stamping, and we use specialized software like LS Dyna to simulate high strain rate sort of motion and how the stresses are sort of affected on sharp corners. And Karina was doing VBAI. And this part's really interesting because you get to read barcodes and numbers from a sample, like going along in a production line. Good stuff. So it was sort of built up into a nice course. By week 10, I was doing welding. Karina was doing VBI tools and vision in LabVIEW. I don't know a lot about that topic. But anyhow, week 11, powder metallurgy, and she was doing motion control. That's where the whole thing is good, but motion control and embedded systems, because I think LabVIEW stopped giving support to motion from 2020 onwards.
Feedback. I love it.
And maybe it shouldn't have done that.
Yeah.
We are still limping along, okay, with old versions of LabVIEW, and which suits the university in some ways because they don't have to upgrade it very often. We'll get to that in a bit, but we're still hanging in there. Then finally, I did powder metallurgy, and Karina got then beginning to see connections with some of the things that I taught and what she taught, motion control and embedded systems, and you'll see a word there called SolidWorks. And that's the beginning of what we would call our little project, where the two parts of the course that seem so different perhaps to you became a bit more joined. And what you're seeing there is, I think, there's a bit of motion control, and on the right-hand side is a sort of a linear, I think we've got a stepper motor that travels along on sort of a rod. And so basically you did your little bits on the LabVIEW bit, and our linear actuator would sort of move along to get that kind of moving. And it worked quite nicely. And then finally, I think I did pattern metallurgy twice, and I think she did a bit of a review. Now we'll get back to motion in a bit. I'm not finished with that one yet. So how are we assessing them? All right, in the first part, they got to do their own, I think I've run that before, but I'm going to run it again. They got to write their own codes and hand it in on a part that they design. And Karina would do a yearly kind of, it'd either be this topic or scales or something like that, something that was involving data acquisition. So there's two basic assignments. Each assignment had an A and a B. Oops. So 2A was more about different manufacturing processes. Sorry, I've made my bit bigger than Karina's, but I mean, it doesn't matter. That was all about casting that particular year. But it's still, you know, interesting. And Karina's bit sort of would be something like machine vision, vision builder for automated inspections. Perhaps these were going along in a production line and you had to identify chips that weren't in the right place or the like. And then we got onto the project. Now this, I think we gave the students about 3 or 4 weeks to do, and it really brought the whole thing together. Now, hopefully I'll play this and everything will run. What this project was about was ice cream. I think it was a machine that would manufacture ice creams. I didn't think of it, Karina did. So if we play it, let's have a look. Is that going to work? Oh yeah. There were 2 bits to it. There was the SolidWorks motion part, which SolidWorks has its own kinematics kind of package and FEA. And that just played. Did that just, how's that going along? Is that doing anything? It is moving. So the head goes along, fills it up with cream and chocolate or something like that. And everyone's happy. Now that's just a standalone SolidWorks thing. There we go. More or less you get the idea. Now these are students who know, like 3 months ago, knew nothing. We are moving along nicely, I think, with them. We get typically the brighter kind of students, I guess, at Sydney Uni most of the time. And this is the Karina bit. which incorporates LabVIEW. I think this might have audio. If we're lucky, we might get audio. No. So you can see that it's
time. Notice as the filler progresses through the holes that the filling LED turns on whilst the Z axis is changed, and the Z position moves from its original position at 20 centimeters to its end position at 15 centimeters, a displacement of 5. Also note that the X and Y positions are updating respectively as the system flows through each of the mold cavities. We will now see the system reach its final row, wherein it will return to its original position for us to re-click the fill operation with a new tray. We are also able to click home at any point to return to the initial state or exit the program. Thank you.
all right. Yeah. So that's where they finally kind of ended up. So you can see your LabVIEW integration controlling SolidWorks. But a lot of work went into that with our IT people. We had to run at times during COVID virtual machines on the Microsoft cluster to get this on Azure computers, just to get this software installed properly, because a lot of students had struggles installing software. A lot of packages had to be installed, checked to make sure that they all talk to each other. Lots of work with Karina and IT going on in the background. So anyhow, that's where we're up to now. And then
the system begins
some student feedback on the course, which is last year was the very last time. I've deleted people's names too, otherwise they get big heads. You see. Good things about the course, really helpful, blah, blah, blah. Oh, Luke is there, pretty helpful. Oh, we go. All right, so the tutors were really helpful. One thing that could be improved, I don't see the relevance of the automation side of the course. I'm a mechanical engineer. You're learning. I find it difficult and time consuming. Yeah, but you don't know where you're going to end up in life.
Yes, I do.
And asking, this is the thing, that whenever you ask students questions and it's taken as face value, you end up with responses like that. However, there's positives and negatives. I just took a sample of the good and the bad. I really enjoyed Paul and Karina's clear and direct teaching, et cetera, et cetera. Expectations were clear, and that particular student said nothing could be improved. So anyway, there's a range of kind of responses like that. It's good to get the students' perspectives, but you've got to, how can I put it, filter out, I don't like this or I don't like that. There's plenty of things we do in life that we don't like, but you know, you're in it, you've got to do it. Students, the mechatronics students typically enjoyed it or found it too easy. Oh, I could have written it in Python. You know, this kind of thing. Yes, you could have, but industry may not use Python, okay? You're using industry grade software. Suck it up is the message. Some mechanicals got a lot of reward out of it. This particular one here, it's a lack of vision, perhaps. You just don't know where you're going to end up in life. So it's another lens to it all. So what happened? Mysteriously, it disappeared. Ta-da! So it became a second year unit of study and it sort of ended up there, but it's run by somebody else, a totally different view of it. And when you go into second year, I've lived in second year for a long time, different sort of student, everything's more basic. So there's no LabVIEW in there. However, I was told, yes, but you can control that subject there, computer-aided manufacturing, and change it into whatever you want. Okay, it's a much smaller, it's an elective subject, has about 60 students instead of 200, 300. The type of students you get in those sort of subjects are people that choose to be there rather than they're forced. everything in year 1, 2, and 3 is more or less, you have to do this. So it becomes a final year elective. It's also available to postgraduate students from around the world that we get from usually China or India, somewhere like that. So this happened about 18 months ago, and there was a lot of, what would we do in there, to change it? I said, well, I can just bring over the stuff from third year. No one will notice. They will, because they're going to then do that for us. That's for the first year. But then the question is, what's the automation part going to be? And so that's been debated, particularly with the cut-off to motion. Hopefully that could be revised one day. No. So it could, we thought about this, perhaps, do we drop the whole motion thing, come up with a completely different sort of project or the like? Another way of perhaps doing it is this. What do you think should be in it? So fine, I'm not going to pass around bits of paper, maybe ask you to raise your hands, all that. So all you've got to do, and if you would do this for us, please, hopefully it can be captured somewhere. If I'll try and log in. If you can just get the QR code, and maybe just in a couple of words that maybe we can decipher, we can research a topic, give us some feedback on what you think should be in it based on what you saw and your own experiences that you think, damn it, the students should know about this. And we all have opinions about universities and students that may have worked for you. There's some good ones here, I'm sure. Yes, and there's some that are challenging. The good, I won't go on about students, but the good students are the ones you sadly don't remember as much as the other ones that use up 90% of your time. The good students are good because they just go along and learn and the like. So if you could scan that code and just give us a little bit of feedback, you can go on to Menti. Our code, sorry.
Oh, yeah.
Got a question? Yes, go ahead.
Yeah, I mean, this is great. I'm also curious to see what people come back with.
Yeah.
Not a question, although I do have questions, but a general statement is that we are trying to build out content and materials that can be used in a university setting to introduce students to, I hesitate to say LabVIEW. It is LabVIEW, but there's also a notion of, well, let's teach them engineering concepts, but let's do it with LabVIEW. They're learning LabVIEW, but it's not about, that's a means to the end of learning PID or control or something like that. So we have a team that we have a team that is building out this library of content. We're working with educators around the world, very interested in this feedback, would also welcome feedback from the room in the moment or tomorrow. I think too, know that we are also keen to identify which schools we should be working with. So obviously University of Sydney is a preeminent one in the area. If there's others, I'd love to catalog who I should be connecting with, who are the professors, what are the departments. Philosophically, one of you may remember we used to have a very, very large academic team. Our approach is a little different this time around. We want to be really focused on curriculum or organizations where students have to interact with the physical world, right? Like back in the day, we were trying to compete with MATLAB and that was silly. So identifying those student-led organizations, those groups, those curriculum where we can help. And in some cases, it may look like the professor wants to teach something. He wants them to use LabVIEW. He doesn't have time and energy to teach them LabVIEW. So maybe an I or a partner does that. So he can tell students, go to that 3-hour workshop and then come in my class and I expect you to know how to use the tool. Anyway, a lot of things in flight. I'm very interested in feedback on the motion front. I really do genuinely welcome the feedback. We have no imminent plans for motion, but it's come up more than once, and so keep the feedback coming.
Okay.
Right, that was
no. Really, that's great. I think that's the end of the. It's a thank you afterwards. I don't normally have thank yous at the end, but seriously, thank you. Thank you for your presence here, and we really do appreciate your feedback through that code. But happy to take questions from the floor.
Has anyone got any questions? Definitely do if no one does. Yeah.
Hi, it's not really a question. It's more a sort of acknowledgement of your good work doing this. So I was a mechatronics student at Monash University. We didn't really have any access to this technically. So not much of LabVIEW, not much of, well, there was SolidWorks, but we did our FEA in Abacus, not in SolidWorks FEA. And definitely no integration between SolidWorks and LabVIEW per se. And really good work. I think that would have really interested me as a student when I was studying. And don't take that feedback from that one student as negative, because he really he wouldn't understand where he could end up. Like, no. I was mechatronics, I didn't know about LabVIEW. Now I'm also working at LabVIEW, so yeah.
I want to tell you a story. When I was in GDevCon in Stuttgart, I met with an engineer there. He's a former CERN engineer. And he told me that the local university had asked him if he could come in and teach LabVIEW. And he was super excited to do it. And so he naturally went to NI and said, hey, NI, I've been asked to teach LabVIEW at a local university, perhaps University of Geneva, I don't know. And I said, no, you'll have to buy that courseware from us. And so he went, and this I wasn't involved, to be clear. He went and wrote his own. And made his own curriculum to teach LabVIEW. And I was like, oh, I'm so sorry. That was like, in many ways, the last few years have been like a toddler playing with a loaded gun. We've made a lot of terrible decisions. So yes, know that we made it way too hard for people to teach LabVIEW in universities. We are changing that. We want to build out curriculum. We have those materials. We made Community Edition free for students. We're looking at ARM native to better support Raspberry Pi and other targets. Actually, what's cool is, well, there's a number of third parties building Arduino-based targets for like teaching in universities that are very, very low cost. Because the reality is too, a lot of students these days are using these low cost targets, obviously like ESPs and Arduinos and stuff. So there's also a big push. CTI. Yeah, CTI. You're talking about CTI, right? Yeah. Okay, yeah, CTI is pretty awesome too. So there's a lot of things. So I guess, just show of hands, who here in some way, form, or fashion is still involved with a university or mentoring students, or even you just know a professor or an organization that you could help with? Okay, so like, if you
and extend that, would want to be involved.
Yeah. Who would want to be involved?
And I was committed. You had the materials to help. You just want to be involved.
Yep. Yeah, we're even looking at working with partners or consultants or champions to contract. Like, let's have you go in and do a workshop to teach university students LabVIEW. So we're still in a building mode right now, so I welcome ideas and feedback. Frankly, we're further ahead with piloting some things in the US because it's just easy. We have some hardware kits that we're sending out. We're doing lots of these workshops at universities all across the country. But right now, my team is trying to figure out how we scale that globally. And I'm not sure exactly how we do that for Australia, but I would really like to.
Okay. I mean, very nice words. Thank you very much. Silent partner here is Karina. I think so. Over a period of 10 to 15 years, I think 2,000 to 3,000 students have gone through us.
I have a. Oh, you finish off your thought.
So the other challenge, the other piece of this, is a number of partners and end users. Somebody just stood up here and said we're hiring, right? And so one of the things we're getting beat up a lot about is I'm trying to hire LabVIEW programmers. Like, there's huge demand for LabVIEW programmers. And so we also need to connect those dots, right? Like, I want to help show students that there's careers, and I also want to catalog where people are trying to hire, but then also make it easy for the people to hire to know which schools, which programs, which professors are cranking out people who already know LabVIEW. And the challenge is twofold. There's people that know LabVIEW, but there's also people that aren't afraid of this thing called test and measurement. I don't know if it's true here. It kind of varies around the globe, but I've heard a lot of feedback that people hire engineers, and a lot of engineers leave school just thinking, I'm going to build stuff, I'm going to design stuff. And like, well, you have to test it too. I'm like, what? That sounds boring. And, and the reality is like also part of the battle is teaching them that test is a really cool and exciting. You get to blow stuff up and break it. Like that's, so anyway, it's a multifaceted challenge, but the other aspect is not just increasing the pipeline, but the number of anecdotes where you're already graduating thousands of students every year.
Yeah.
We have to help industry connect to those individuals and find the professors who are teaching to help bridge that gap.
Our electrical engineering school, well, we've got a new dean now who's electrical engineering, and he wants to see our school mix up with electrical engineering. And I think they've got a complete laboratory of LabVIEW, an Elvis laboratory or something. So there's people in electrical engineering as well.
Awesome.
So
yeah, I should get info.
Yeah.
Contact info.
Okay.
Just one last comment. Sorry, Paul. The last few years, my organisation, I'm a similar company to Karina. We're an alliance partner, and we've been working with a local university where they do a final. They can either do, you know, a project at uni, or they come and do 6 months work integrated learning.
Yep.
And that's been an awesome opportunity for us to. This man right here is one of the outputs of that, certified LabVIEW developer. So they come in, work with us for 6 months, but we can get them learning LabVIEW, you know, within a month or two, and then they're actually being productive. A lot of other universities only do like 12 weeks work experience, and that's kind of not enough.
Yeah.
But 6 months is enough time to learn and actually contribute, and it's been an awesome way to get people learning and building stuff. You know, each student that we've had through has had a totally different experience from the next.
Yeah. Great. Okay.
Sorry, Paul, one more final one from me, because I'm very interested in this topic as well. So I work with UTAS, University of Tasmania.
Okay.
We mainly work with research projects, and they've got a site license, and they could quite easily use LabVIEW in their teaching courses.
Yeah.
How would you recommend approaching the university? Who should I talk to try and get it into the learning curriculum so that we can produce those engineers to recruit into software?
So you've got a LabVIEW license, and you just need someone to teach it.
Yeah, well, I can teach it.
Oh, you can teach it. Well,
so I'm an alliance partner similar to Karina and Chris.
you need to form, like, it's like networking. You've got to meet up with an academic. I mean, manufacturing is so broad, and this is another problem. One reason for the whole LabVIEW and Karina thing is she's actually involved in manufacturing. It's very hard to find people in Sydney who are involved in manufacturing. I mean, when I was a kid, I mean, Redfern was full of factories and the like, and that's all changed. Sydney's just not a manufacturing city anymore. You've got to find that common ground where somebody has the vision to say, this is what we need.
Yeah, okay.
You know.
So it's more on the lecturer level than the dean level sort of thing.
Oh, it could be a dean. Could be a dean. Yeah.
I mean, does BRIMAC work with University of Tasmania?
Yes, Dimitri's just left.
Okay. So, I mean, I have the same challenge, man. Like so if we have, you know, Sandia is a big school customer, and they said, I want to hire out of University of New Mexico. It's like, okay, well, does the NI seller, does the partner, like, do we have any former students? So as you navigate that, I'm interested to navigate it with you. So.
Thank you.